All right, the common derivatives. So first off, derivatives is a calculus topic. So there's a good chance you're not going to understand why we're doing a lot of what we're doing, but the hope is that you can memorize some of these patterns and get used to how they work, so that way you don't even really have to understand. All right, what I'm going to mainly focus on is a lot more of the patterns here, and how you can maybe use this flashcard. And I would say with that as well, though, I will show you how you can derive some of these, but most of the time you probably just will have to kind of take them for granted. Okay, so here we go. So first off, let's start with looking at the first two, sine and cosine of x. So you really do just have to memorize these, right? But it's not too bad because sine just becomes cos, and then cos, when you turn it back into sine, it just gets a negative to it. But I do want to highlight something here. So, right, so again, we have that the derivative of sine is cosine, and then we have derivative of cosine is negative sine. But what if we keep going? So what if we take the derivative of negative sine of x? And you may not know this, but the negative will just carry over. So then now we just have sine of x, and the derivative of sine of x is cos of x, right? And so then what if we keep going again? And so then we have negative cos of x, derivative of negative cos of x. Well, negatives carry, and what's the derivative of cos of x? We know from the above that is negative sine of x. And then negative of negative sine of x is just sine of x. So what do we notice? We started with sine of x, we took the first derivative, we then took the second derivative, we then took the third, and then the fourth derivative of sine is actually itself. And you can do the same thing with cosines, and you would see the same thing. So what this is saying, as we can kind of see, is if you take the fourth derivative of sine, it's sine, or if you take the fourth derivative of cosine, it's cosine, which is really cool, meaning if we wanted to know something like the 10th derivative of sine of x, well, again, we know every 4 we're just going to get back to sine. So like in many of our other tricks, we can kind of just cast out 4s until we can't anymore, which then leaves us with the second derivative of sine. So the 10th derivative of sine is actually equal to the second derivative of sine, which we see as just right here, negative sine of x. So that's a cool thing with those. Okay, so then now the next two, right, sine of 2x and cos of 2x. So these actually, the way you're just going to have to memorize these for now. But if you're more curious and you want to learn more, look up something called the chain rule. I wouldn't recommend learning the chain rule of derivatives until you understand basic derivatives, but what essentially happens is you just take the derivative of sine or cosine, right? And then you just throw another 2 in the front. And again, you just had to memorize those. There's really no trick to those. All right, now this next one, a times x to the n. Okay, now you can memorize this formula and probably get it, but if you want to think about it just more conceptually, what you're doing is you take the power and you bring it down to the front, right? Typically, we'll say we're bringing it right here, and then because we bring it down, we have to decrease by 1. So it'd be a times n, and then since we brought the n down, it has to be n minus 1 up here, which, as you can see, that matches that, right? So that's how I'd recommend you think about it. You bring the n down and multiply, and then you have to decrease, right? And then the last one is this, or the last two. First off, well, actually, we'll look at this. This one you just learn. If you have e to the x, it's just e to the x. That's just how it is, which is actually really cool. That you could take, so in other words, the 12th derivative of e to the x is just e to the x. No matter how many derivatives you take, it's always going to be e to the x. And then this is also cool. So you have ln of x is equal to 1 over x. So the derivative of ln of x, somehow a natural log just becomes a simple fraction. Not simple, but you know what I mean. Okay, little notes. First off, there's no stipulations on this n. This n could be positive, could be negative, could be a fraction, like 3/2. This will work no matter what, right? You just kind of have to follow the same formula. That might take some getting used to. Now, I said I would show you the derivation, so let's go ahead and do that. And your derivation is going to use something that's called the definition of derivative. Again, you don't have to know this like at all to be able to use any of this. This is just for people who want to know kind of where this comes from. So we just write that write d dx, right? That's how we notate derivative of f of x, right? Where f of x is our function, is equal to the limit of f of x plus h minus f of x divided by h, right? And so then if you ever wanted to know what the derivative of an equation is, you would never do this on a test, right? But this, like if you had all the time in the world and you're like, what is this derivative? This is the formula you can use. Note that it won't work for things like sine and cosine. You need a little more than just this. You'll need some properties and other things. But generally this can kind of do it. So for example, we could look at like f of x equals x squared. Right, now first off, we know what the derivative is because of our formula, right? We said bring the power down, so then it's 1 times 2 times x, and then 2 minus 1 is 1. So this should be 2x. But we can get it with this formula as well. So if we have the limit as h goes to 0 of f of x plus h, right? F of x is x squared, so x plus h squared, and then minus f of x, which is just x squared, divided by h. And so then this becomes x squared. Let me always make sure you don't remove your limit too early. X squared plus 2xh plus h squared minus x squared divided by h. Right? Notice how these cancel, and then we can divide by h. And so then we get the limit as h goes to 0 of 2x plus h. And notice that when we solve this limit, right, if h goes to 0, then if h is 0, then it's just 2x. And boom, we actually got it. We derived it, right? So now we know through the long way, not just the shortcut, that the derivative of x squared is 2x, right? So that's how you can kind of use that. Again, generally, that's not something that you will use much outside of just proving things to yourself, but it's still nonetheless cool to see. And that is the common derivatives flashcard. Again, a lot of these you'll just have to memorize for now, but as you take upper level math up to calculus, you will start using other methods, and these will kind of become second nature.